Hi everyone, this project is PV-FET multilevel inverter, a new symmetric multilevel inverter topology with reduced number of switches. In this topology is superior to existing multilevel inverter configuration in terms of low total harmonic distortion. The proposed topology uses pulse width modulation (PWM) technique to control the gating pulses. In this we have started from lower level inverters, and till now we have completed the 15 level inverter, open loop and closed loop both. The circuit complexity is drastically reduces and it is suitable for medium and high power application. A TSD for the output is quite low and when compared with the conventional inverter. Now we are going to see the multi-level inverter 15 level open loop. In this we have started with the first PV-FET PV panels. This one is a PV panel, and then boost converter. We have created a subsystem and it is fed to an inverter. This is a 15 level inverter, and this sources, the voltage sources consist of it consists of 7 voltage sources, and each voltage sources consist of a PV panel and a boost converter, which given individually connected to each sources, and then the gate pulses in a switch. In switch we connect a subsystem. In this subsystem we have pulse generators. This pulse generator generate pulse width and the delay time. We have calculated it accordingly and provided it. And now this PV panel, we designed the PV panel for an output of 17.4 volt. The 17.4 volt will be boosted up to 35.29 volt. 35.29 volt. Why we design like this is a total output of an inverter is to be produced for 240 volt for 35 volt, 35, a total of 7 voltage sources, and totally it will be of 240 volt output. And now the solar cells are connected in series. Each cell will produce in 0.6 of voltage sources, and totally we have connected 1 2 3 4 5 it's 30 1 2 3 4 5 24 29 cells, which produces 17.4, and we connected it parallel to produce the current. Each panel produces 7.34 amps of current, and in parallel it's a 2, so it produces 14.68 volt for 14.68 amps. Then now we are going to see the inverter operations. Now the inverter switching actions. This inverter switching action comes from, it starts with this voltage. This voltage starts with this voltage, and the switch. This is a switching sequence: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. Totally it consists of 17 switches, which is a proposed model. From the voltage is starting from here. Switch 1 and 2 conducts, and this switch conducts. Again these 3 switches, again these 3 switches, and these switches. The voltage is closed for one level. The output waveform. Let's look out for output waveform. And again for the second voltage, it conducts the switch 1 2, and again this one closes and this one closes. Now we got the output waveform. And this is the output waveform for our 15 level inverter. Now you can see the 15 level inverter. This is for voltage V, and this is the second voltage, and this third, 4 5 6 and 7, total of 7 voltages: V, 2V, 3V, 4V, 5V and 6V, total of 7 voltages. And this action takes place with 7 voltages. The closing of the voltage circuit, closed loop, which is connected, all the switches are connected in series. The closing of first voltage gives the first level of voltage output. Second voltage gives the second level of output. In this we have an special advantage, which if we want this voltage to conduct, we need this switch to be on. if we want to skip this voltage, this switch will be on. If this switch will if this switch is on, this voltage will be skipped, and this switch is on, the voltage will be conducted. Likewise, all the voltages are conducted. The pulse generator calculations are done likewise. If a single switch, when we see this pulse generator, for a single switch, this much of pulse generator is required, and this much timings and this much pulse width, this switch will be conducted. Hence the calculations are done, and we have connected all the pulse generator in an OR gate and created a subsystem, and the subsystem is fed to a switch, and then the total circuit is completed. We can see the output. Similarly, the closed loop, we have done the closed loop for 15 level inverter. Okay, this is the closed loop circuit. In this closed loop circuit, we can see the same thing, but we have done the boost converter is closed looped. You can see the circuit. We have taken the pulse generator in the boost converter, and the boost converter is fed to the closed loop circuit, and this closed loop circuit as and this closed loop, we can see the closed loop output. This is the closed loop output we are getting. It is 70 volt of closed loop output. 70 volt of closed loop output, and the final closed loop output is for 15 level is this one. Now you can see the output. Okay, disturbance we have provided for the solar. The solar panel will always the sunlight will always will not be equal, so the disturbance should be provided to the panels. So the disturbance we are given here. This is the disturbance, and the disturbance at 0.8 we have provided at 0.8. So the output of this disturbance solar panel, you can see from here it is 17.15 volt at 0.8. Here the 0.8 is there for a time period of 1. We have run the simulation at 0.8. You see the disturbance created, and the required and the correct output is provided. It is 17.4. It is 17.4. You can see in display it is 17.4.
Now we are seeing the hardware circuit. Just move on to hardware. You can see this transformer, two transformer. This is a 12 volt 1 amp transformer. This is 12 volt 0.5 amp transformer. This transformer provides a source of the inverter. Because of you cannot using the PV panels, so we simulate the DC sources with the help of rectifier. Rectifier convert the AC to DC power supply. The capacitor helping to filtering circuit, and then we using a regulators ICs. The regulators ICs are help to the required voltage. This regulator IC will be 78015. The regulator IC 12 volt regulator IC. We are using the 12 volt regulator IC 3 because of we done the 7 level multi-level inverter. So we require the 3 voltage sources. Each rectifier source, each rectifier circuit is replicate the single PV panel. Okay. Just move on to the next circuit. We using a PWM pulse generator in simulation. We can using the Arduino. Arduino is a simple thing to program, and is open source. So we are using the Arduino. We can use to microprocessor and microcontroller. Okay, we can. This is also microcontroller. Okay. You produce the 12 pulses because of 7 level multi-level inverters. 12 switches are using. 12 switches are 12 pulse generator we are required. So we cannot MOSFET is IR of 840. IR of 840 cannot activate the gate pulse in 5 voltage. Arduino can produce only the 5 voltage. So we can boost the supply with the help of driver circuit. Driver circuit is the given to the driver circuit. With the help of the Arduino, we can produce the gate pulse. Okay, just we give it the pulse to the driver circuit. Gate pulse S1. This is switch will be S1, S2, S3, S4, S5, S6, S7, S8, S9, S10, S11, S12. This switch configuration will be connected to the across to the driver circuit. Okay, we just a simple thing. The driver circuit, Arduino produce the gate pulse to give it to the driver circuit. The driver circuit will be boost the voltage to 5 volt to 12 volt to trigger the MOSFET. We can obtain the 7 level multi-level inverter. That's all.